up next will be probability games. Now, basically, every game we play is under probability, right? The chances of winning and losing is there is no assurance in them, so everything is under probability. Now, but when it comes to studying probability as a topic, we have 3 basic games that you basically almost see in your questions, and those are our coin games, our fair dice, or simply known as our Ludo game. And the last is our card game. So we'll start by studying our coin game. So now basically we all know what a coin is. And every game being played under a coin game is simply in the toss of a coin. Now this is if this is a coin, right? Now we all know that a coin is made up of just 2 faces, which is our head and our tail. So in the flip or in the toss of a coin, it's either you have a head or you have a tail. So in our coin game, our possible events, in a coin game we have just 2 possible events, which is our head, represented with letter H, and our tail, represented with letter T. Alright? So for every coin game, the probability of picking a head. Now if our coin game is made up of just 2 events, it means that in every coin game, our maximum number of sample spaces for a single toss is always equal to 2. Alright? So for a single toss of a coin, we have that probability of picking a head is equal to, now we have just 1 head in a coin, and our total number of sample spaces is 2, and probability of picking a tail is also 1/2. So for a single toss of a coin, or for a single flip of a coin, the probability of picking a head is 1, and is 1/2, sorry, and probability of picking a tail is also 1/2. Now when it comes to questions probability games, now this coin game is one of the areas where you can find one of the simplest questions. Alright? Now but you can see how complex, or let's say little bit complex areas under this coin game. And where can they come in? Now you can have a situation whereby a coin is tossed more than once. Okay? Let's say 2, 3, 4, or 5 times. Or you can have a situation where you have 2 or 3 coins being tossed simultaneously. Now in such situations, you cannot use your 1/2 and your 1/2 for head and your 1/2 for tail in solving them. So how do you tackle questions like this? Now when you have, or let's say when you encounter a question that involves the toss of a coin more than once, or that involves the flipping or the tossing of 2 or more coins simultaneously. Now we solve them using what we refer to as our coin tree. So what is a coin tree? Now we can simply define a coin tree as a diagram that helps us to easily trace the probabilities when you have 2 or more coins tossed simultaneously. Now look at what a coin tree looks like. Now let's assume that this is our coin. Now let's assume that this is our coin, right? Now just like we said earlier, if a coin is tossed once, you have just 2 possible things that can happen. It's either you get a head or you get a tail. Alright? It's either you get a head or you get a tail. So this is for the first toss or for a single toss of a coin. Now what if this same coin is tossed again? Or let's say this same coin is tossed for the second time. Or you have 2 coins being tossed simultaneously. Now our coin tree will give us an extension for the second toss. Now for the second toss, we'll have from here, this is supposed to give us a head and a tail for our second toss. And this is also supposed to give us a head and a tail for our second toss. This is first. Now what if the same coin is tossed for the third time? Or let's say 3 coins were tossed simultaneously. Now this our coin tree will also give us an extension for the third time. So we have our head, our tail, our head, our tail, our head, our tail, our head, our tail. Now this is for the third toss. If the same coin is tossed for the first time, when you have 4 coins being tossed them simultaneously, you extend this as much as you need to. Now, but I want to show us how we can solve coin questions using this coin tree. Okay? I want to show us how we can solve coin questions using this coin tree. All right, let's see our very first scenario. Now, this is our coin. If a coin is tossed once, they are supposed to have head and tail, right? So if you have to find probability of picking a head, or of seeing a head when a coin is tossed once, our total number of sample spaces is we have just head and tail, so we have 2 all over. How many heads can you see here? We have just 1 head. The probability of seeing a head is 1/2. While the probability of also seeing a tail, our sample space is still 2. So this is for head, and this is for tail. For tail, our sample space is still 2 because we have just head and tail. So I'll have 2 all over. We have just 1 tail here, which is 1. So just like I said earlier, for a single toss of a coin, we have the probability of seeing a head to be 1/2, and probability of seeing a tail to be 1/2. Now, what if this coin is tossed twice? Or you have 2 coins being tossed simultaneously? Now, just like I showed you earlier, now this branch is for our first toss. Now, for our second toss, I'll have to introduce a second set of branches. Second. So here we have our head, our tail. Here we have our head and our tail. So if a coin is being tossed twice, or you have 2 coins tossed simultaneously, our total number of possible outcomes becomes, now look at the ending part, we have 1, 2, 3, 4. So we have our sample space to be equal to 4. Okay? So with this sample space now, you can solve any question that comes along with your coin being tossed twice or 2 coins being tossed simultaneously. So you can be asked to find probability of a head occurring 2 times or a tail occurring twice from the possibility of tossing a coin twice. Now, the question simply means if a coin is tossed 2 times, that you should find the probability of 2 heads appearing those 2 times. Now, how do you solve such questions? Now here, this branch stands for our first toss. Now this second segment stands for our second toss. Now from here we have that our sample space is 1, 2, 3, 4, right? So from this branch, what will this branch give us? This branch will give us 2 heads. Now this branch will give us a head and a tail. A head and a tail. Now this branch will give us a tail and a head. While this branch will give us a tail and a tail. Okay? So these are the possible things that can occur from tossing a coin 2 times. So if you toss a coin twice, or if 2 coins are tossed simultaneously, it's either you have a head and a head, or you have a head and a tail, or you have a tail and a head, or you get a tail and a tail. So from this now you can answer any question on that probability. Now you can ask for a probability of attaining 2 heads. Now how many 2 heads do we have? We have just 1 2 head here. So probability of seeing 2 heads, probability of head will be 1/4. And probability of tail will be, we have just 1 tail here, so we have 1/4. Now what about the probability of a head and a tail? Now here we have a head and a tail, and here we have a tail and a head. Now these 2 are the same. So we have the probability of a head and a tail appearing is, we have a head and a tail appearing 2 times. We have 2/4, which is equal to 1/2. Now that is for scenarios where you have just 2 tosses of a coin, or you have 2 coins being tossed simultaneously. Now what if you have a coin being tossed 3 times? If you have a coin being tossed 3 times, Now that means we'll also have to extend this our branch to have for our third toss. So for our third toss, we have this to be head and tail. We'll have this to be head and tail. We'll have this to be head and tail. Then we'll have this to be head and tail. So if we have 3 tosses, our possible outcomes will be 1, 2, 3. 3 heads, head, head, head. We have 1, 2, 3. That is 2 heads and 1 tail. From here we have head, head, tail. From here we have head, tail, head. We have head, tail, head. From here we have head, tail, tail. So we have head, tail, tail. Now from here we have tail, head, head. So we have tail, head, head. From here we have tail, head, tail. We have tail, head, tail. And from here we have tail, tail, head. Have tail, tail, head. And from here we have tail, tail, tail. Have tail, tail, tail. Now these are the possible occurrences when you have a coin tossed 3 times, or when you have 3 coins being tossed simultaneously. Now what are our total number of sample space? Remember, these are single events, right? So, and this group of events are our sample space. So what is our sample space? Total number of sample space is 1, 2, 3, 4, 5, 6, 7, 8. So it means that if a coin is being tossed 3 times, our sample space is always 8. Or the total number of possible occurrences or possible events is always 8. So from this you can solve any question under probability. Now you can be asked to find probability of having 3 heads. And also, what's the probability of having 3 heads? Now, how many 3 heads do we have here? We have just 1 3 heads. The probability of having 3 heads, probability of 3 heads is equal to 1 all over 8. Remember, it is number of heads all over our sample space, 1 over 8. You can be asked to find probability of having 3 tails. Probability of having 3 tails, 3 T's, is also 1 over 8, right? Because we have just 3 tails. You can also be asked to find probability of having 2 heads and 1 tail. Probability of having 2 heads and 1 tail. So you just go to your sample space and look out for where you have 2 heads and 1 tail. Now where do we have 2 heads and 1 tail? Here we have 2 heads, 1 tail. So this is 1. Here we have 2 heads, 1 tail. This is 2. Here we have 2 heads, 1 tail. This is 3. Where else do we have 2 heads and 1 tail? Okay, so we have 3 events that contains 2 heads and 1 tail. So for the probability of 2 heads and 1 tail, it is 3 all over 8. It is 3 all over 8. You can also be asked to find probability of having 2 tails and 1 head. Just like what you did under 2 heads and 1 tail. You go to your sample space and look out for scenarios where you have 2 tails and 1 head. So here do we have 2 tails and 1 head? Here we have 2 tails and 1 head. Here we have 2 tails and 1 head. Here we have 2 tails and 1 head. So probability of 2 tails, 2 T's and 1 head is still 3 all over 8. And so on and so forth. So this is it under coin 3. And believe me, this is what you need most under coin games. Okay? Once you're able to understand this coin 3 and how it works, you can be able to solve any question under your coin game. Now the next type of game we'll be looking at will be our fair dice.